All right, so let's have a look. This is going to be a couple of videos, hopefully, on things like how to differentiate, and I'll put it in a number of steps for you, so you can kind of see uh, the way you'd set this out, the order in which you'd do this. So I think having a series of steps, if we're going to create some sort of mastery. So the first thing is step one, we're going to write out the function. So in this case, I'm going to choose this one here. It's nice and simple. Let's say it's going to be y equals, let's choose one, x squared plus 7x plus 6. Okay, the next step we do is we're going to express it as a differential. So expressing that as a differential, quite a few different ways you can actually do this. Of course, if this was f of x, then you could say f dash x or f prime x equals. If it's in this form here, we can say we're going to differentiate y with respect to x, and that would equal something. Or we could say we're going to differentiate this thing here with respect to x. So I'm going to go d x squared plus 7x plus 6 with respect to x equals. This is a bit more unusual. You wouldn't normally do that, but you could do that. There's nothing stopping you doing that. All of them mean precisely the same thing. But if it is y, I probably wouldn't make it into an f prime, or g prime, or an h prime, or whatever the name of the function was. So let's go ahead and solve this anyway. So we've got y, so I'll just restate it. So y is x squared plus 7x plus 6. So now I'm going to say dy dx is equal to, and step 3 is take each coefficient of x and multiply it by its power. So let's have a look. Well, the coefficient of x here is 1, and 1 times 2 is 2. I'll put an x there. Plus, take the coefficient of x here, which is 7, and multiply it by its power. Oh, sorry. Oh, yes, so that's correct. I don't know what I'm doing anymore. 7x, coefficient of x, 7x is 7, multiply it by its power, which is 1. So that's going to be 7. Now, I could write an x there, but I'm just going to leave. Oh, actually, I will. Whatever, yeah? Now I'm going to go to this next step, which is reduce the power of each x value by 1. And so here, the value was 2, but I'm going to reduce it by 1. So 2 minus 1 is 1. So it's 2x to the power of 1. But we don't write 1. It's just 2x, yeah? So I can get rid of that. And so we're going to end up with dy dx is equal to 2x plus, now this is a 1 at the moment, yeah? But we're going to reduce it by 1, so I'm going to make it minus 1. So 1 minus 1 is 0. Of course, we don't need to keep that there either. And 7x, well, x to the power of 0, anything to the power of 0 is just 1. So it's like saying 7 times 1. So it's going to be 7. And there is my completed differential. Now you'll notice I should have actually put one more step in here, which I'm just going to put in now. Here we go. This is going to be any constants fall away. And we do have a constant. We've got the plus 6. So the plus 6 falls away. So the plus 6 was a plus 6 here, and that just falls away, leaving us with our answer. So just to go through that again, we have the function. We're going to write it as a differential. That means differentiate y with respect to x, or you could say the change in y with respect to x is equal to, now I'm going to take the coefficient, which is 1, there's really a 1 there, and go 1 times 2, and that's 2, there it is. I take the power, which was 2, reduce it by 1, so it now becomes 1. So it's 2x to the power of 1, which of course is just 2x. I've got 7x to the power of 1, and 7 times 1 is 7, there it is. and I'm going to reduce the power by 1. What is 1 at the moment? I'm going to reduce it by 1. Well, 1 minus 1 is 0, so it's 7x to the power of 0. And 7x to the power of 0, I'll put a 0 there. Anything to the power of 0 is 1, so it's 7 times 1. And 7 times 1 is 7, and the 6 falls away. And that's how we differentiate.